Alright, we're going to try this thing live. We're going to see how this goes. We are balancing equations, and then we're going to name the type of reaction. Let's see, number one, we have two sodiums, one carbon, three oxygens, two hydrogens, sulfate and a sulfate. This one is already balanced. I'm just going to put ones in there because it's already balanced. It does not follow a standard pattern of our reactions. Number two, let's see, we have one calcium, one oxygen, oh, two chlorines. I'm going to put a 2 here and fix my chlorine so that they match on each side. It also makes the hydrogens match. The oxygen and calcium already matches, so that is a balanced reaction. And it is a double replacement reaction. Number three, we have bromine. There's two of them, but on the other side there's only one, so I need to double the bromine. That also changed the potassium to 2, so I'm going to double this. That changes the iodine to 2, but it's already at 2, so now it's balanced. That is a single replacement because the bromine is replacing the iodine. Number four, we need a 2 here to balance that one. And that is a synthesis reaction as the two compounds are coming together to make one compound. Ooh, this one's a toughie if I recall. Let's see, the nitrogens are split apart, the hydrogens are kind of funky. This one's going to take a second here. I think I end up putting a 2 here and then realizing the nitrogens don't work, and that 2 is because there's two hydrogens there. But then when I come over here and look at the nitrogens, they don't work, so I have to start again. What I did learn from that, though, is whatever number is here, this number has to be double that because of the hydrogens. So if I put a 2 here, I need to put a 4 here to keep the hydrogens equal. And then I'm going to put a 2 here so that I have 2 nitrogens plus 2 nitrogens for 4 nitrogens. And that is actually balanced right there, 1, 4, 1, 2, 2. That is not a standard reaction type. It's a weird reaction, not a standard. In number 6, we have nitrate and nitrate, so I'm going to multiply this by 2 to get the nitrates equal. Multiply this by 2 to fix what I just did to the silvers. And the chlorines are already fixed, and this is a double replacement reaction. Number 7, I'm going to go for a least common multiple of oxygen here to get them both to 6. And when I got both of the oxygens to 6, that changed the sodium and the chlorine, so I need to fix the sodium and the chlorine. That is a decomposition reaction. Number 8, this is a non-standard weird combustion. I'm going to write Na as far as the reaction type because it's a super weird combustion. Let's start off with a 3 here and a 2 there. That gets our hydrogens equal, and then we'll put a 2 here to get our nitrogens equal. But our oxygens are kind of train wreck because this is 2 oxygens plus 3 oxygens, it's 5. So I need 2.5 there. I'm not allowed to do that, so I double the whole thing. I'm going to double the whole thing and put a 4, 5, 4, 6, and get rid of the previous mistakes. There we go. 4, 5, 4, 6 is balanced. Number 9. Let's see. We have 3 sulfates. Multiply this by 3. That's 6 hydrogens. And multiply this by 3. The only thing left is the gallium. That's sorted out now. And this is a single replacement reaction as the gallium is pushing out the hydrogen. Number 10. This is one where whatever number we put here has to match the number we put here because there's only one carbon in each spot. And so if we try a 2 and a 2, it does not work because the oxygens don't add up properly. But those two numbers have to match. Let's try a 3 and a 3. So the carbons match because they both have a 3 in front of them. The oxygens on this side are 6. Here we have 3 plus 3, which is 6. So we have found a balanced way for this reaction. It is not a standard reaction type, though. This one's pretty easy. It's a synthesis reaction. Let's see, we have phosphate. So I'm going to put a 2 here to fix the phosphate. We have hydroxide and water. My advice was to scratch out water and replace it with hydrogen hydroxide. And then you can probably balance it. There's 3 magnesiums. Multiply this by 3. That's 6 hydroxides. Multiply this by 6. 6 hydrogens. You already have 6 hydrogens. And that is a double replacement reaction. Hydrogen and phosphate swapping with magnesium and hydroxide. Number 13. Let's see. We have 3 acetates. Multiply this by 3. 3 hydroxides. Rewrite water. Anytime hydroxide and water kind of there together. Put a 3 in front, and I think I'm balanced now. That rewrite rule is most commonly used if you have a double replacement, like we do this time, with hydroxide and water. Number 14 is actually the same as one of the questions earlier. It was 1, 4, 1, 2, 2. We already went through that one. Accidentally appears twice. Let's see, number 15, we have 3 sulfurs. We're going to multiply this by 3. That is 6 ammonia. It's going to put 6 here. 6 bromines. Going to put 2 here. 2 irons. Already got 2 irons. That is a double replacement. And now we're on to the writing reactions. You have to write the compounds correctly before you work out the balancing. So number 6. We have iron and sulfur reacting. They're both normal elements, so nothing too tricky there, just iron and sulfur. They're making iron 2 sulfide, and you can see on the right where I've got the iron's a +2, sulfur's a -2. Those 2 charges work, so that's the formula, FeS. In number 17, we have magnesium and water, which make magnesium hydroxide and hydrogen gas. And then 18, we have copper 2 oxide, it's a +2 for copper, and oxygen's a -2. Those 2 balance each other out. And then we have sulfuric acid. Sulfuric acid would actually come from sulfate. And then on the product side, we have copper 2 sulfate, copper's a +2, sulfate's a -2, those balance each other out, and water. And then when you go to balance the reaction, it already is. Reaction types. So this is a synthesis reaction. This is a single replacement reaction. And this is a double replacement reaction. 19. Oh, we have this Brinkelhoff thing here. That's a reminder that these 7 elements are diatomic. They're never alone. If you ever see oxygen, it's O2. If you ever see nitrogen by itself, it's N2. And just a minute ago, we had hydrogen by itself, and it was H2. So I write the formula for table sugar, then oxygen, products for carbon dioxide and water, carefully balance and add together. Kind of the same thing with 20.